what I said too. You have to be able to identify the explanation text. Now, I want you to watch a movie. Who wants to watch a movie?
I do.
You do? Yes. Okay. So, we are going to watch a movie. It's about a phenomenon that you have said. So, one of the phenomena that you have said. It can be tsunami, it can be earthquake, it can be disaster, any kinds of disaster. So I want you, it can be corruption too. So I want you to watch it, think about it. I'll make some pause, and you can guess what the part of the movie, why I make the pause, okay?
Okay.
So you watch it twice. The first one, I make some pause in it, and then the next, you watch it without the pause.
In 479 BC, when Persian soldiers besieged the Greek city of Potidaea, the tide retreated much farther than usual, leaving a convenient invasion route. But this wasn't a stroke of luck. Before they had crossed halfway, the water returned in a wave higher than anyone had ever seen, drowning the attackers. The Potidaeans believed they had been saved by the wrath of Poseidon, but what really saved them was likely the same phenomenon that has destroyed countless others, a tsunami.
Okay, that's the first part. So you have to think about it, what it might be in the genetic structure of explanation text.
Although tsunamis are commonly known as tidal waves, they're actually unrelated to the tidal activity caused by the gravitational forces of the sun and moon. In many ways, tsunamis are just larger versions of regular waves. They have a trough and a crest, and consist not of moving water, but the movement of energy through water. The difference is in where this energy comes from. For normal ocean waves, it comes from wind. Because this only affects the surface, the waves are limited in size and speed. But tsunamis are caused by energy originating underwater, from a volcanic eruption, a submarine landslide, or most commonly, an earthquake on the ocean floor, caused when the tectonic plates of the Earth's surface flip, releasing a massive amount of energy into the water. This energy travels up to the surface, displacing water and raising it above the normal sea level. But gravity pulls it back down, which makes the energy ripple outwards horizontally. Thus, the tsunami is born, moving at over 500 miles per hour. When it's far from shore, a tsunami can be barely detectable, since it moves through the entire depth of the water. But when it reaches shallow water, something called wave shoaling occurs. Because there is less water to move through, this still massive amount of energy is compressed. The wave's speed slows down while its height rises to as much as 100 feet. The word tsunami, Japanese for harbor wave, comes from the fact that it only seems to appear near the coast. If the trough of a tsunami reaches shore first, the water will withdraw farther than normal before the wave hits, which can be misleadingly dangerous. A tsunami will not only drown people near the coast, but level buildings and trees for a mile inland or more, especially in low-lying areas. As if that weren't enough, the water then retreats, dragging with it the newly created debris and anything or anyone unfortunate enough to be caught in its path. The 2004 Indian Ocean tsunami was one of the deadliest natural disasters in history, killing over 200,000 people throughout South Asia. So how can we protect ourselves against this destructive force of nature? People in some areas have attempted to stop tsunamis with seawalls, floodgates, and channels to divert the water. But these are not always effective. In 2011, a tsunami surpassed the flood wall protecting Japan's Fukushima power plant, causing a nuclear disaster in addition to claiming over 18,000 lives. Many scientists and policymakers are instead focusing on early detection, monitoring underwater pressure and seismic activity, and establishing global communication networks for quickly distributing alerts. When nature is too powerful to stop, the safest course is to get out of its way.
Can you guess it? So there are two parts in the, what we call? So there will be two to watch it one more time and then ask one of you to mention the parts. Okay?
In 479 BC, when Persian soldiers besieged the Greek city of Potidaea, the tide retreated much farther than usual, leaving a convenient invasion route. But this wasn't a stroke of luck. Before they had crossed halfway, the water returned in a wave higher than anyone had ever seen, drowning the attackers. The Potidaeans believed they had been saved by the wrath of Poseidon. But what really saved them was likely the same phenomenon that has destroyed countless others.
Now, based on the short movie, based on the video you have seen, can you guess what is actually explanation text? Is it a text? Fiction or non-fiction? Fiction or
Non-fiction.
non-fiction. So explanation text is a non-fiction text. What it is explaining or what explanation text say? About, yeah?
Text that gives us information about something.
About something. How something is explained here. Why and how. So the key is how or why. Something happened. So explanation text is a non-fiction text that say something or phenomenon happened. How and what in sequence order. Okay, good. Now, so what is the generic structure then? The first one?
General statement.
General statement. Okay, the second one?
Sequence of explanation.
Sequence of explanation. Now, I want you to work in a group of, let's say, 4 students in a group. I'll give you another video and then you will analyze it. You'll tell me, or you can write down what is the general structure and the tenses that use in it. Mostly, they are
Simple present.
simple present. Good. Now, just gather in a group of 4 students, 4 students, 4 students, 4 students, and the students in the back, 4, 4, 4, 4. Okay, I'll give you a paper to work. 1, 2, 3, 4. This is for your group, or you can gather all together here. So I'll give you a cover. One group will work in write down the answer in the paper. So each group will get first make sure that you write down your name, class, and student number. Okay, work in groups, so you can turn your chair and work together.
Been through a devastating series of wars, and a slow recovery seemed to be underway. But nature had other plans. After 2 years of poor harvests, the spring brought heavy rains and cold, flooding the rivers and causing crop failures from the British Isles to Switzerland, while odd-colored snow fell in Italy and Hungary. Famine, food riots, and disease epidemics ensued. Meanwhile, New England was blanketed by a strange fog that would not disperse as the ground remained frozen well into June. In what came to be known as the Year Without a Summer, some thought the apocalypse had begun, a mood captured in Lord Byron's poem, Darkness. I had a dream, which was not all a dream. The bright sun was extinguished, and the stars did wander darkling in the eternal space, rayless and pathless, and the icy earth swung blind and blackening in the moonless air. Morn came and brought no day. They had no way of knowing that the real source of their misfortunes had occurred a year ago, thousands of miles away. The 1815 eruption of Mount Tambora on the Indonesian island of Sumbawa was what is known as a supervolcano, characterized by a volume of erupted material many times greater than that of ordinary volcanoes. And while the popular image of volcanic destruction is molten rock engulfing the surrounding land, far greater devastation is caused by what remains in the air. Volcanic ash dispersed by wind can blanket the sky for days, while toxic gases such as sulfur dioxide react in the stratosphere, blocking out solar radiation and drastically cooling the atmosphere below. The resulting volcanic winter, along with other effects such as acid rain, can affect multiple continents, disrupting natural cycles and annihilating the plant life on which other organisms, including humans, depend. Releasing nearly 160 cubic kilometers of rock, ash, and gas, the Mount Tambora eruption was the largest in recorded history, causing as many as 90,000 deaths. But previous eruptions have been even more deadly. The 1600 eruption of Peru's Huayna Putina is likely to have triggered the Russian famine that killed nearly 2 million, while more ancient eruptions have been blamed for major world events such as the fall of the Chinese Xia dynasty, the disappearance of the Minoan civilization, and even a genetic bottleneck in human evolution that may have resulted from all but a few thousand human beings being wiped out 70,000 years ago. One of the most dangerous types of supervolcano is an explosive caldera, formed when a volcanic mountain collapses after an eruption so large that the now empty magma chamber can no longer support its weight. But though the above-ground volcano is gone, the underground volcanic activity continues. With no method of release, magma and volcanic gases continue to accumulate and expand underground, building up pressure until a massive and violent explosion becomes inevitable. And one of the largest active volcanic calderas lies right under Yellowstone National Park. The last time it erupted 650,000 years ago, it covered much of North America in nearly 2 meters of ash and rock. Scientists are currently monitoring the world's active volcanoes, and procedures for predicting eruptions, conducting evacuations, and diverting lava flows have improved over the years. But the massive scale and global reach of a supervolcano means that for many people, there would be nowhere to run. Fortunately, the current data shows no evidence of such an eruption occurring in the next few thousand years. But the idea of a sudden and unavoidable civilization-destroying apocalypse caused by events half a globe away will remain a powerful and terrifying vision, less fictional than we would like to believe. The winds were withered in the stagnant air, and the clouds perished. Darkness had no need of aid from them. She was the universe.
Okay, so the second video is about supervolcano. Okay, so I have already gave you paper to be work with your friends. So now work with your friends. Okay, class, I say that some of you, all of you have already finished in your group. So now I'll invite one of the group to come in front. Maybe Williams and Lillian groups to present your findings. Okay.
So let's go.
Friends.
So according to what we just saw about an explanation video, we would like to share what we found about it and what we analyzed about it.
So in our opinion, that video can grab the reader's attention because it's very interesting, and of course it explained in a very interesting way.
want to tell you guys about the general structure, general statement of these videos. The first one is effect of volcano eruption in many countries, and then darkness. The second sequence explanation is about erupted ash and toxic gas that blocks.
Yeah. The eruption of the super volcano emits gas, toxic gas, and also ash, and which blankets the atmosphere and cools the atmosphere down, and causes fog and famine, which disrupts the natural cycle in many countries, not just around the volcano itself.
So as an explanation text use the simple present for its grammar, and we found proof about it, and one of them is that the video says that it lies right under the UWM National Park. So the word lies is simple present.
Okay, good. Give them